Okay, so I can see Madhavi, Tushar, Satish, and Ananya. So let us start. Maybe others are all informed and people will be joining. And this particular class, which I already discussed with all of you, this is basically AWS data engineering training, which I'm going to start today. And I'm going to give you a high-level introduction about the AWS data engineering and data stack and how it is going to be unique in the market compared to other data engineering like services and all. So let me share my screen. I hope you're able to see my screen.
Yes, yes, sir.
Okay, cool. So when I talk about data engineering with AWS, right? So there are other cloud services also in the market, like Azure data services are there, GCP data services also available, and there are some cloud databases like Snowflake is also people are using for data engineering. But why AWS data engineering? So how it is different from other like cloud services, and what are the different data stack available in AWS, I will discuss today. And before jumping into this AWS data engineering also, first of all, I want to give you a high level overview on like what is data engineering as well. And when I talk about like AWS, so AWS, which is like Amazon Web Services, when Amazon started in 1995 as an online bookstore, they slowly moved to the other like business like DVDs, online selling DVDs online, and they move to so many different like other uh, domains and areas where they scatter their business. And they mainly moved into the electronic side and where they started selling them and along with online books and all. And in 2006, when Amazon officially, when they started like AWS, like nothing but Amazon Web Services, and which will became the major cloud service provider in the market in implementing cloud computing like in most of the like projects. So when they started with only two services, and slowly it has been increased, and now we can see there are more than 200 plus services in AWS environment, which are helping so many customers in different like projects. And when you go back and talk about like AWS, so AWS is nothing but a collection of remote computing services which will be combined to build a cloud computing platform that Amazon is offering by using Amazon.com website. So this is not like a software where we can go and install. We need to access the AWS platform using a web portal only. We need to create a account. How you create a Gmail account? You need to create that, and you also need to create your username and password. By using that particular username and password, you can log in through AWS Amazon.com website, and then you can access all the 200 plus AWS services from the portal. And AWS is also located in more than 200 like 20 plus geographical region with 12 plus services. And each region, you go and see, each region is wholly contained within a single country, which means that every country has a AWS or Amazon data center available to support that region. For example, in Indonesia, you have a like data center in Jakarta. Singapore itself has its own region, and in India you have like the data center in Mumbai, which are like these data centers are very highly secure data centers. In US we have four regions, so every country contain more than like two or more regions and minimum one region, and all the data customer data is getting maintained by these data centers, and that will be accessed by most of the customers through internet only. Without internet, this is not going to be accessible. We need a decent internet connection also. And apart from that, you also need to understand like what is this cloud computing? See, here some people may already have knowledge on what is cloud computing. Cloud computing is a group of resources which are connected and that can be accessed from any location and using any device and during any time. 24 by 7 we can access these services. Like for example, any database server or any Linux server I want to access, or any big data cluster, all can be accessed through multiple devices here, either laptop or tablet or even smartphone I can access. And while even I'm in a travel, if I have a decent internet connection, also I can access. And 24 by 7, these services are also available. So no need to wait for someone need to go and start the services. These services will be available 24 by 7, where you can access using any device from any location. That is how the AWS is offering the customers. Then how it is offering? We go back and see, like in AWS, AWS is providing like pay as you go. Pay as you go means just like our credit card. You need to go use and pay. You can use it. All the AWS services and service wise, you will have charges, and these charges will be like calculated according to the monthly billing, and you can access from anywhere, anytime using any device. And economy of scale, I can easily scale up with very less charges. Scale up means we can increase the capacity of my server, or I can increase my storage. I can store my data in AWS environment. I can increase the size if needed also, and very flexible. So I can use this particular AWS services very flexible, where I can go and use it from any particular location using any device anytime. And expertly managed is one of the important thing which we need to understand, because all these AWS services will have a separate dedicated team to manage them. For example, S3 bucket is a service to store the data. So you have a separate Amazon S3 team. Redshift is a database which you can store the data in the form of relational databases. So Redshift team is available to take care of Redshift service. So like that, every service is expertly, we have people of subject matter experts are available to manage that service, and then they will try to use this particular team to manage that individual service with individual separate teams. And what AWS is offering? AWS is offering availability, scalability, and pay as you go. So what is meant by availability? So availability means data availability. So assume that a scenario where you are required to give a presentation, and you not in India, maybe you are traveling to some other country, maybe Singapore. And before cloud was there, how people used to carry, if I ask you? People used to carry with a pen drive. Correct, right? Everyone? Without pen drive, I cannot go and carry the data externally. We also got external hard disk later, but before that, people are using pen drives, and if you used to copy the files into pen drive and they used to carry that, and suddenly if the pen drive is damaged, what is my situation? So I cannot access my data. So I'll definitely will be in a high risk. So to overcome this particular kind of challenges, the solution is I can create if I have a cloud access, I can create a Google Slides also. I do not even need to carry a pen drive also. I simply need to create a Google Slides presentation, and I can simply start creating in the Google Slides itself, and I can access the Google Slides presentation from any location or any device anytime. So here Amazon provides in 11 nines availability, 99.999 like that, 11 nines availability, almost like 100% availability of the data to the customer without any downtime. That is one of the main reason why customers are getting attracted with the AWS environment. Second thing is scalability. So scalability means nothing but the ability to grow the size of the environment, like I want to increase my hard disk size, or I want to increase my storage, or I want to increase my server capacity. I want to go and do instantly, and I want to eliminate the estimation of my infrastructure capacity needs in advance. In particular, that scenario, I need to think about my scalability also. Scalability means increasing the number of servers. So I can instantly increase the number of servers very, very easily with few clicks in the AWS environment. I need to go to the particular tab and I can increase by giving the number of servers, how many servers you want. So the scalability also another important feature companies are trying to start using this AWS environment. Third one, pay as you go. When I say pay as you go, no upfront expenses will be available, and no long-term commitments also we need to think about, because all the ongoing cost will be pay as you go. You need to use and pay. Once after you finish, you feel that your utilization is done, you will get a monthly billing according to your consumption of the resources. Every service will have a different way of how AWS will charge the customer. AWS Redshift, they will charge differently. S3 bucket, they charge according to the storage. And Redshift, they charge according to the compute and storage both. Athena, they charge according to the amount of data you are scanning through your query. And Lambda, they will charge you how much time you are running your code in their server. So every service will have its own way of billing. So that billing also you can go and review if you have an administrator account. So separate Snowflake billing tab will be there where you can go and monitor your billing also. Sorry, AWS billing also. AWS tab will be there, billing tab. And apart from that, you also need to see AWS is on top and followed by Microsoft and the next Google. We also have other clouds also in the market like Alibaba Cloud, Oracle Cloud and IBM Cloud also. They are very far behind because the companies are not interested to use those particular clouds because they are not flexible like AWS or Azure or GCP. So AWS is on the top and AWS is the leader in the cloud side. So whenever I talk about the service, even the data services also available in AWS, particularly in AWS environment. Will discuss about that. And when I talk about this AWS data engineering, we understood about what is AWS. And when I talk about like data engineering, how data engineering was started. If you go and see, and before 2000, how the data was getting managed. The most of the data was getting managed through databases. Every company, if you see 90s, between 90s and the 2000 decade, every company started centralizing their data into databases, RDBMS databases, and every company was very busy in how to store and manipulate their data for their application development. That is what happening between 1990 and 2000. As soon as we reached to 2000, there was a big revolution in the data side, where data warehouse got started, the birth of data warehouse. Why we got data warehouse? Because traditional real-time environment is not suitable for the analysis. So every company started thinking like, how can we manage that? So that is where the historical data has been separated and it got stored as a data warehouse. So data warehouse is always a data for the analysis, and which is the historical data only, not recent data. And most of the companies started leveraging databases such as Oracle, SQL Server, and some set of CSV files. Also, people were using to load into the like ETL process, and ETL process used to run as a job, and that is being used for creating the pipelines to migrate the data using ETL process. So Informatica was one of the very famous tool in early 2000 decade, where people were extensively using that to create ETL jobs and migrate data from source to target. Along with Informatica, Data Stage, SSIS, Ab initio, BODS, these tools also are very famous. And as soon as data has been centralized into a ETL process, into a environment, people started using BI tools such as Crystal reports, business objects, and MicroStrategy and SSRS. All these tools also people started using to build their dashboards and reports. This is the source for this particular reports is the conventional data warehouse which companies are building. And what were the sources of for this particular conventional data warehouse? The internal products data and the CRM application data also. This is only structured data. In conventional data warehouse, people were storing only structured data which is in the form of rows and columns. And even the structure of the data also like relational database data which is like tables which is contain a set of rows and columns. And what is the required knowledge to work on this particular conventional data warehouse? We need to know SQL or PLSQL if it is Oracle, TSQL if it is a SQL Server data warehouse. And what is the data loading frequency? Companies were used to wait for the daily transactions to complete, and then they used to go to the like end of day, and after the business hours are completed, every company used to start a batch process to load the data from source to target using a ETL set of ETL jobs. So this is how the conventional data warehouse was built. Whenever you move to like early 2000, there was a big revolution in the data side. Suddenly the data growth got increased. What is the reason for that? Who can answer this? Anyone can answer. What can be the reason the data growth was suddenly increased after 2010? Anyone?
Advent of internet. Uh,
Internet is increased, correct, agree. But what might be the reason? What caused the internet to use that much highly? That's what my question. Anyone can answer. Everybody like may have experienced that, but the reason why the data suddenly got increased, for that there was a reason. Why companies or people experienced high data growth? Who can answer? You can guess it. But one answer I got, that is correct, internet usage got increased. But why internet usage got increased? That's what my question. Any idea? No idea? Social media, right? Correct or not? After 2010,
yes, yep.
social media was very extensively people got started using. Like Facebook got invented in 2007. Eight, Facebook slowly got so many customers, and because the Facebook got success, we got LinkedIn, WhatsApp, YouTube, Instagram, Twitter. Many different social media companies also got emerged. Everybody started giving a provision to upload videos, images, documents, everything. Suddenly, what happened? The unstructured data got increased. So before that, there was only structured. Companies were having no challenge at all to manage the data. As soon as they start experiencing unstructured data, everybody were unable to store the data in the normal structured database because structured databases like Oracle, SQL Server were designed to store the data in the form of rows and columns. We cannot store unstructured data in that. Then the birth of big data warehouse started. That is where Hadoop came into the market, right? In 2011 and 12, you see, every company started moving their data warehouse to big data warehouse. Even I moved to big data during that time period. When I was working in MasterCard, the conventional data warehouse, I migrated to big data warehouse first. Because their data also got increased suddenly. And then slowly the big data warehouse converted to big data lake also. So that is how when you are processing the data, your data variety got increased, data volume increased, and data velocity also increased to accommodate all these the big data came into the market with Hadoop, HDFS and MapReduce together. HDFS for storing the data, MapReduce to process the data. And slowly MapReduce also after some time was not able to manage live streaming data and which was taking so much amount of time to process. Spark came into the picture and slowly replaced MapReduce. And then now Spark and HDFS is the combination in the market. And every company extensively started using this particular Spark and HDFS to manage the data. And MicroStrategy and Power BI tools also got invented after this only, to manage the huge amount of data to build dashboards. And social media data also got added to the sources of the data along with internal products and CRM data. And sentiment analysis, for example, sentiment analysis is one type of application where people are extensively started using. And data varieties got also added from structured to semi-structured, and unstructured data also got added. And required knowledge also was mostly Java because people who knows Java, they were easily used to learn this particular big data framework because all big data frameworks were written in Java. After that, MapReduce got demised, became very slow. Spark came with Scala and Python and it replaced MapReduce. And the data loading frequency also was only batch before that, and live streaming data capturing also started. And big data warehouse slowly converted to big data lake. And what is the difference between a big data warehouse and big data lake? Who can answer? If I ask you, what is the difference between them? Major.
So, yeah, so Sri, big data, there is a subtle difference.
Mhm.
Big data lake is a place where all the structured, semi-structured, unstructured data all
Agree.
come together, right? And what is the other one you said?
Big data warehouse, I'm asking, and big data lake.
Right. Lake is like all the different formats of data, right? It
Mhm.
came in. And warehouse is specifically for building the warehouse where structured data, where there is a relational concept among the tables. We build tables and there is
Exactly.
a
Very good.
relational
Correct.
concept. Yeah.
When I say data warehouse, the difference will come like data warehouse only will manage structured data plus historical data only in general. When you come and see data lake or big data lake, you will capture both batch data like historical data and live streaming data, and you also manage, as you mentioned, structured, semi-structured, unstructured data and quasi-structured data also. So there is no restriction that I only can manage structured data in big data lake. You need to manage any kind of data. If you receive a group of images, you should be able to store and manage. If you receive a group of videos, you should be able to do that. If you receive a group of voice messages, also you have to do, because every unstructured data also will be managed in the big data lake. But that is not for big data warehouse. That you have to understand. So slowly companies started leveraging these big data lakes and they started building new live streaming applications. Say, for example, credit card fraud detection systems, money laundering detection systems. These particular applications require live streaming data. Without that, we cannot build them. Correct or not? Can I say a credit card transaction is a fraudulent after 1 week? Is it correct to say? His customer will accept it. If you see that as a bank, there was a fraudulent transaction in a customer account where he lost his card, and after that there was a fraudulent, and you after 1 week, if you go and say there is a fraudulent, will the customer accept? No, right? Do you agree that no customer will accept? No, they will ask, why didn't you inform me, or why didn't you block the transaction? So credit card fraud transactions, very risk. There is a very risky like application. Money laundering also very risky application. So you need to immediately block them or immediately flag them also. So that is where the real time recommendation engines also. Like for example, if you go to Amazon also, you will see Amazon also provides some recommendations when you buy any product. How do Amazon knows you will like this product? Because they will try to track your activities in the website step by step. Whenever you log into like Amazon website, Whatever the pages you visited, which products you selected, and which pages you navigated, everything they will track. And they will try to see which pages you visited. According to that, they will try to provide you some recommendations to buy. That is very common in most of the e-commerce and many different other products also. That can be done only if you are able to capture live streaming data. But how can I build this kind of applications? Because you need so many frameworks. When the big data started, so many frameworks came to the market. All these frameworks also not easy to learn. Every data warehousing engineer need to adapt to these big data frameworks, and nobody is ready to do learn also, because it is not easy for one single person to learn all this. I know how much pain it is to learn all this, because when I was learning to build a big data lake. So this is a challenge for developers also. At the same time, challenge for companies also to maintain the big data environment, because not maintenance is not easy. Patching, upgrading is very hard. Even performance also requires manual intervention to optimize. And I need to do memory optimization. And it is not easy to find a technical resource as well. And not easy to manage a big data cluster, which is a open source. I need a dedicated person to do that, like Hadoop administrator and a dedicated team also. And also I cannot reuse a person who is already working in conventional data warehouse to learn this and do, because nobody will be ready. And rare resource means high salary also they will demand. So these are some of the challenges where companies also started experiencing even after big data ecosystem is a success. But the challenges were very common for every company. As a developer experiences the challenge, plus the companies also experience the challenge. So that is where started companies started thinking about the cloud services also, because the data growth was very high. The internet was highly growing. The utilization, as you mentioned, after 2011, 12, and 13, it was very high utilization was happened, and the data growth also was very high. If you see after 2018, 19, and 2020, you can see how many smart devices got invented after COVID also. Everybody started using online classes. Everybody uses online, like uh, everything online, instant. Food is online, cab service online. So everything is online. So if you want to do everything in online, so the utilization also will be very high. So ultimately what happens? Data growth also become very high. And everyday companies are the industry experienced high data growth every day. To manage this one kind of data, which is a high volume with high different varieties and high velocity, traditional environments are not supportive. We need a instant, that instantly I need to scale up, instantly I need to scale down, I need to instantly increase the size. So that is where cloud came into the picture. So cloud services started helping the customers to reduce their infrastructure cost also slowly. So everybody now can create a database server by using AWS RDS service. I do not even need to depend upon a DBA. I can get a big data cluster using EMR service. I do not need to depend upon a Hadoop administrator as well. So like that, I can create my own database server, my own big data cluster, all this. That is where this particular AWS is also helping the customers to save their time. I want to create a Linux server. Earlier, people used to depend upon a Linux administrator. Now, I can use a EC2 service. So AWS contains so many services to achieve that. And when I say talk about data lake, so I need to build a data lake in such a way where it can manage the structured data, unstructured data, and semi-structured data as well. All this data should be able to we can able to store and manipulate, and I need to retrieve also. So a data lake should be able to manage this kind different varieties of data, and every data lake, if you go and see, which is a centralized repository which will allow us to store all unstructured, semi-structured, structured together with a high scale also. This is where the data lake in the cloud also started. And what data lake will do? Data lake will help you to store the all data in one single location, and we can access from any device. and it will supports different file formats and supports fast data ingestion and consumption of high volume of data, schema on read, designed for low cost storage, and it will separates storage and compute, also provides protection and security rules automatically. All these are available in AWS cloud. That is why AWS is very famous for data engineering activities. And also every like operation you perform in a ETL, that slowly converted into ELT after big data came. So big data, when it came into the market, it slowly changed the process to ETL to ELT. Before big data, it was only extract, transform, and load. After big data, it converted to extract, load, and transform. That is what companies started doing. They,
Sri,
hmm, tell
yeah,
me.
sorry to interrupt, Sri.
Hmm,
So I just wanted to understand, like,
hmm,
that with AWS, right?
hmm,
Since you mentioned the
hmm,
ELT concept, right?
hmm, hmm,
So ideally, in most of the projects
hmm,
nowadays,
hmm,
how the tech stack or how the operation is being performed. I know that it is today is the introductory class, but I
hmm,
just wanted to know,
hmm.
like, since we have AWS and then Snowflake, most of the cases Snowflake is also being used, right, as a
Correct,
data
correct,
warehouse.
correct.
Now, AWS has its own glue, right, which
No,
you can
Redshift,
use.
Redshift.
No, I'm talking in terms of ELT or ETL
ELT
features.
is ELT is glue. Correct, correct. You're right.
Correct, right? So
Hmm,
now in most of the projects, if any project is using AWS and Snowflake,
hmm.
mostly is it like are they depending on any other ETL vendors like in IDMC or Talent, or they are using their in-house AWS ETL capabilities to load it into either to Redshift or to Snowflake?
See, that depends, right? So Snowflake, if I'm using Snowflake, I do not need glue. So I can use something else also. We have tools available in the market, like for example, to perform this ETL process or whatever it is,
Uh-huh.
we have Matillion is there. It's for Snowflake, or DBT is there, or we can
Uh-huh.
use. There are other tools like Fivetran is there and Colis ETL. There are
Uh-huh.
so many other cloud tools also came into the market, keeping Snowflake in mind.
Uh-huh.
Which is Snowflake? So
Okay.
Snowflake is a separate database. So because
Uh-huh.
they are hosting their application Snowflake on any one of the clouds like either AWS or GCP or yeah, Azure. I can use any cloud there. There is no restriction that I only need to depend upon AWS. They will give you a choice
Right.
of selecting any cloud. If I use AWS means my data and the compute will be maintained according to AWS services. Like for example, if I use AWS to host my Snowflake while creating, you can select the AWS. Then
Uh-huh.
automatically your data will be maintained in the S3 buckets and your compute will be maintained using the EC2 services. Assume that you select Azure. What happens? Automatically your data will be maintained in the blob storage and your compute will be with the Azure VM instances. So according to the cloud you selected, they will maintain the data and the compute in their environment. You do not need to inform them. Just need to select the cloud only. That is Snowflake.
Okay. Okay.
But in
Okay. But
AWS, it is not related to that Snowflake, right? AWS is totally different. It is a separate.
correct. Correct.
Hmm,
Correct, correct. That part I got it. But the thing is, if
hmm,
you see in most of the projects and all, right,
hmm.
since AWS has a better integrity with Snowflake till date, right?
Exactly.
Though
Correct.
it is, though you can integrate with Azure or GCP, but most of the projects are being run in AWS environment only, right?
Correct.
So in most of the job titles, I could see along
Hmm,
with Snowflake. I
hmm,
understand Snowflake you can do ETL, ELT through other tools.
hmm.
They are asking AWS capabilities also. So my
Correct.
point is how it helps to build, for the senior role or senior data engineer role,
Uh-huh.
keeping Snowflake in mind.
Sure. So when I say AWS is Snowflake, right, you should know how to integrate with AWS services with Snowflake, correct? No? For example,
Right. Mhm.
my data should be sitting in S3 bucket. Snowflake never allow
Uh-huh.
you to directly load the data anytime.
Mm.
You should have intermediate storage like AWS S3, for example, if you are using AWS environment. Your data, when you are migrating or loading into Snowflake, you should first place the data into S3 bucket location, and then you need to establish an integration between S3 bucket and Snowflake.
Right.
That is what companies are looking for if you are using AWS. The same thing if it's Azure, right? You need
Uh-huh.
to know how to integrate from blob storage to Snowflake. That is same.
Lovely. Hmm.
So depends
Hmm.
upon, but most of the utilization is on AWS because when Snowflake started, Azure was not even there.
Uh-huh. Right, right.
Correct,
Hmm.
no? So you can
Hmm.
imagine why AWS having more integration with Snowflake is because when Snowflake started to the company started building Snowflake product, there was
Right.
that time only AWS was the only cloud that time. So they were keeping AWS in the mind and they started building the all their like
Capabilities.
capabilities, features, everything. As soon as
Hmm.
Azure started, right, slowly they are adapting to Azure as well, but not like AWS.
Hmm.
That is why
Hmm.
you can see more AWS projects, to be honest. If you go and see in Europe
Hmm.
side, right, there
Uh-huh.
will be more Azure projects because Europe companies are more rely on Azure side. You can't even find any AWS projects that much heavily. So if you go that
Hmm.
side, right, Snowflake is investing more on Azure side also, some of Europe companies. So you need to see because most of the US companies are already adapted with AWS, right? So Snowflake already established there. So they are using AWS with like a Snowflake as a combination, and also
Mm-hmm.
any particular real-time integrations also they want to perform. Snowflake is allowing now by using, for example, for real-time data processing, we have Kinesis so in AWS
Mm-hmm.
side. So we can use Kinesis for processing that. And if you want to go and from on-premise also you have to move, you cannot directly move. First you need to pull from the on-premise environment to, for example, assume my data is coming from IoT devices, manufacturing. First I need to
Okay.
capture all those messages and I need to place in a Kinesis data store. And from there
Mm-hmm.
I need to push into the Snowflake environment. That is what companies are doing. So everywhere
Mm-hmm.
you need an intermediate storage for Snowflake. But if you
Yeah.
are doing directly in Hadoop in AWS, right, you do not need
Mm.
a intermediate storage, no. So directly, my integrations will be very easy. Assume that I want to push into Redshift database. What
Right.
I can do, I can simply push into a Kinesis Firehose, and from there I can directly integrate with Redshift also. So here, what is the benefit is if you use all AWS services, your life will be easy because the integrations will be very easy because I can easily access one service from another service. Only when you are moving out of AWS only you need to think about the integrations and challenges only. Correct or not? Are you getting what
Correct.
I said?
Correct. 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 Yep.
Yeah.
Yep.
So
Got it.
now when I say data sources here, data there are so many data sources available in the market. So all these data sources you see here, it may come from ERP services or weblogs or IoT connected devices or video like cameras, and there so many sources will come. But how to go and collect this data and try to connect to or ingest into Snowflake environment, sorry, AWS environment, you have to see. How you are going to store is also depends. There are so many storage services are there, like S3 is there. When you are going to store the data, you need to go and decide. We have like any structured data, I need to use DMS, data migration service. This will help you to migrate the data from a particular RDBMS, like a database, like for example, on-premise RDBMS database to like a cloud databases. So from there, I can directly access the data. Or it is a real-time environment. I was telling about Amazon Kinesis. And any particular like data which is like key value pair, I can use DynamoDB and DocumentDB also. So all this data, once you centralize here, that data will be stored in a storage service called S3 in AWS environment. S3 is one of the service where we need to store that. So we need to understand about AS3 is a service, serverless storage service where you can go and store the data. And then after I receive the data, I should be able to store my data in the S3 bucket here as intermediate storage. And this S3 is going to help you to divide that particular S3 in the form of buckets, and each bucket again into folders. So I can segregate into folders, I can push the data into S3 bucket. Whenever the data is available in S3 bucket, any service can access that. Any service can access that data. I can directly use this S3 bucket data also and access from any like access services like, for example, from Athena, I can access S3 bucket data directly. I can select the data also by running queries, or I can use the Redshift like database. I can load the data into Redshift and I can use it. I can push into DynamoDB also. So according to my choice, once after my data is coming and sitting in S3 bucket, then I can use that according to my demand. So most of the projects are their objective is to first to push the data into this particular cloud storage. Once the data is available in cloud storage, they are performing the actual processing, extract, load, and then transfer people are doing, right. The transformations are happening only after it will be moved to the S3 bucket. Hope everybody is following the ELT process. So here sometimes what happens, even the data may come into from the big data environment also, from the on-premise. Then also you should be able to capture into S3 bucket. And then from what we did for one of the project, we migrated from on-premise big data lake to cloud big data lake. So cloud EMR big data lake. So what we did, we used the intermediate storage as S3 only. And as soon as our data is coming into this S3, from here we will try to divide the data into structured, semi-structured, and we used to store into the big data lake according to the requirement. So what usually it will help us. Let me show you. Glue here will help you to go and create a ETL job as you mentioned, and according to my requirement, Glue catalog will allow you to store the metadata. And once my data is available in S3, I can leverage Glue catalog with metadata and I can push the data into any of these particular services, and I can access this data from either Athena or from EMR or from Redshift, or I can use Elasticsearch. Any of these services can access this data. So EMR indicates Elastic Map Reduce, nothing but a big data cluster, Spark cluster compute, and Redshift, a database, AWS database in the cloud, which can manage and process petabytes of data, and Athena, a serverless query engine, which will help you to extract the data directly from S3 bucket files, and it can provide some analytics on top of it. So all this process, once after you complete, the consumption may happen in different ways. The my users, end users can be anybody, right? It can be ML team, machine learning team, or it can be a dashboard team, or it can be a business intelligence team, whoever it is. Their job is to consume the data. So when you see this end-to-end pipeline from here to here, as a data engineer, our responsibility is to how you seamlessly migrate the data from source to target. That is where we are going to learn throughout this particular like training, how to create a seamless end-to-end data pipelines with use cases, and how to utilize these services and which services are important as part of the data engineering pipeline. We are going to learn throughout this journey. So some of the services like Redshift, S3, Glue, Athena, EMR, and DMS, Kinesis. We learn so many services available here, but we learn them one by one, and how to go and utilize them and how to integrate them as well. When you are learning EMR, you need to create some PySpark jobs. So to accommodate that, we learn PySpark. But to learn PySpark again, I need Python. So I am going to teach Python also. So as a data engineer, nowadays everybody learning Python, and the prerequisite also people are looking for SQL. So you should know them. So SQL, Python, PySpark are very, very common for any data engineer in the market. If you go to even Azure side also, these are common, or AWS also it is common, even GCP also it is common. So we will learn them. So, but how you are going to integrate them is important. That is what we are going to learn step by step. Okay. So I'll just stop here. So any questions from anyone?
So Sri,
Hmm.
Sri, I have one.
Hmm.
You mentioned all these services, right, for
Hmm.
AWS
Hmm.
data stack.
Hmm. Hmm.
So, like, my point is, how we are going to learn this? What is the mode? You for each services,
Hmm.
like how we can execute hands-on on
Hands-on.
like
We are going
how you
with
will approach
we are
it.
going to we are going to learn with hands-on with use cases. With
Uh-huh.
use cases. For example, if I say Redshift, right? We know what is Redshift and we learn about Redshift, but how you can integrate Redshift with, for example, S3 and along with Lambda. And we are going to learn with integrating services, not like only Redshift we learn. We know how to use Redshift, we'll learn about that, but at the same time, we should know how can I directly migrate the data from S3 bucket to Redshift, how to utilize Glue catalog or Glue to do that, or how can I leverage when you are moving the data or processing the data, high volume of data from the EMR, how to use PySpark, how can I use Lambda to run the PySpark job. So we will learn like that. If my data is sitting in a real-time processing engine, how can I go and use Kinesis to pull that data? And how can I push into the my big data cluster by using PySpark job? How can I go and use Spark streaming to process the data? Or I want to go and run some analytics or data validations once after I load it. Then how can I use Athena to do that? Or how can I go and store my data which I need to store in the form of key value pair? How can I use DynamoDB to do that? So we
Got it.
learn like that. You understood, right?
Yep.
Yeah,
Thanks.
we will learn according to, because it is not like, as I clearly mentioned, it is a real-time use cases oriented course, not like service oriented. You need to understand that. Okay.
Sure. Thank you.
Okay. Deepak, coding expertise you definitely need, because data engineering is nothing but you are going to maintain the data engineering pipelines. So it is not like Power BI or any visualization tool. You definitely need to understand about how to do the coding, like for example, PySpark coding, because most of the jobs which we are going to write here is PySpark coding and a bit on SQL part also when you go to Athena and the Shift. So you need to do some bit minimum intermediate level coding is there. On top of it, also need to sometimes do some advanced coding as well if needed. Got it? Deepak, I hope I answered your question. Okay.
Uh, Hello.
Yeah, Deepak.
Tushar, yes, sir. No.
Tisha, tell me. Sorry, tell me.
Regarding, so what will be the duration of this course?
So this is a weekend batch as of now. I'm planning. So this will be I'm
20.
planning for 10 weekends, 2 days, like Saturday and Sunday, 2.5 hours to 2.5 hours.
Okay, okay. And
Hmm.
as my background is I'm a PL school developer.
Okay, okay,
So I'm having a more than 10 plus experience in support and data warehousing and such kind.
understood.
So, is it means
Hmm.
after this course, can I able to shift and how much experience I need to show in data engineering?
See, you are already doing data engineering, but you are doing through database, correct?
Yes, yes, yes. I'm
So, so because you are already doing data engineering, so you are using database engineering, but here only tools will change, correct? No?
yes,
Whatever you did, that is only ETL processing you did, correct? No, ETL I can say like that too. You are performing some database programming, but you are doing some database operations through database you are doing. But here you are going to like include some semi-structured data, and also you will learn about how to do that in the data engineering entirely in cloud. You got it right. So you can showcase like you are already having some knowledge in SQL part, and also like you are going to learn about PySpark and all, right? You
yes,
can
yes.
mention like 4 to 5 years after this course.
Okay, okay,
Yeah.
okay. And for to expertise in this area,
Mm.
we need to focus on SQL, Python, and PySpark, and
Mainly,
AWS. Correct.
correct.
Okay, okay,
And
okay, okay.
also I missed to mention about we are also going to learn about the orchestration part, which is companies looking for now in the market is Airflow. So I'm going to
Yes.
cover, yeah, I'm going to cover Airflow also.
Okay, okay. Airflow, step
Ah,
function, something like
correct.
I heard about that.
Yeah, step functions are basically AWS specific service, but
Okay.
Airflow is actually open
Now,
service, open
now
source.
market airflow is more demandable.
Exactly, yeah, yeah. So we are going to cover airflow also, but usually AWS itself is having a service called managed airflow. So we are going to see how to leverage airflow and then how to leverage managed airflow also. Clear?
Yes, yes.
Okay, okay.
So I have one more question. Like for writing Python, right? Since
Mm.
it's a vast area because we have a
Correct.
lot of things.
Exactly.
So with respect to data engineering, is there any open course or like you have any list of things that we need to do
Yes.
prerequisite? Like
No, see, I'm going to cover Python anyway. So no need to go over any
okay,
prerequisite and
okay,
all. Because I
okay,
request people to follow whatever I'm going to teach in Python. Also, I'm going to cover only that is needed, not everything. For example, I cover Python
Okay.
basics and then advanced Python like pandas and NumPy, which is going to help you to understand about data engineering in Python. We do not need, I should not be a Python full stack developer, right? I need to know how to manage data engineering in
right.
Python. So I'm going to cover that part which is required. That is only needed also because you may go and see, as you mentioned, Python is very vast. So we are going to learn about only what is needed. That I'm
Right.
going to usually nowadays I'm covering Python in every of my batches because became Python became very common in for every
Right.
course, right? Even in
Any
Snowflake
data
also,
engineering.
even in data engineering, sorry, any data engineering, data science also. I mean, so when I say Python, right, even Snowflake also needs Python somewhere. So I will teach Python even Snowflake batch also to manage Snowflake using Python. So I by default will teach Python in every class. So we'll go and learn about Python from scratch to up to data engineering part because that is needed to
Okay.
learn PySpark also. That is the reason. Clear?
Are you going to cover PySpark here, Sri?
Yeah, yeah, PySpark, definitely. Definitely, PySpark will be
Okay.
covered. PySpark, we are going to learn about PySpark with data frame operations and Spark SQL and Spark
Okay.
streaming. I'll cover everything. Yeah, that is needed because to process some of the like big data and all, you need PySpark. Here we need to write the code in the EMR cluster to execute. So definitely you need to know. Clear?
Okay.
Yeah. Yeah. Thank you.
Okay. Any other questions from anyone?
Yes, Sri, I have little bit confused between Azure data engineer or AWS data engineer.
This is a AWS data engineer, Deepak.
Yeah, I know that this is a
Uh, uh,
AWS
uh,
data
uh,
engineer, but
you
which one is good for, if I'm comparing the market wise and the job wise, which one is good?
see that is in the reality. See, both are like at the same page because both are competitors. So as I mentioned earlier,
Yeah,
also right.
right.
You go to US
Yeah.
market, most of the market is on AWS side. If you come and see in
Okay.
Europe side, Europe market,
This is
you see majority in Azure side. But in India you will see
right.
both. See, that is
Hmm.
not like 100% I say AWS is only covered or Azure is covered, but most of the projects are already in AWS because Azure came very late, no, recently, like
Yeah,
five
Azure
or
coming very late, right?
so that is the reason most of the companies are looking for AWS because even if you go and see Snowflake side also, as I mentioned as per Onion question also, Onion question, Snowflake is also mainly like they invested more on AWS integrations only. You can go and see. So my preference even also will be AWS data engineering only because most of the like companies also preferring AWS services more compared to Azure side because Azure is still emerging. It still takes some time. It's not like people are using only
Okay.
AWS. Azure projects are there, but companies side, if you see, medium-sized companies and small-sized companies are focusing more on since they are starting from scratch, they are using Azure, but who are already in AWS, they are using AWS data services only.
Okay.
Yeah, AWS data engineering
Okay.
is on the top already, all the time, as of now.
Okay. This is a weekend batch, right?
Yeah. Correct, Deepak.
And the duration will be 1 hour daily or 2 hour on weekend basis
Two
every
and
weekend.
2.5 hours Saturday and Sunday.
2.5 hours. That means
2.5
5 hours
hours
in a
and
week, right?
2 days. I will cover the 5 days in the 2 days. I mean 5 hours. I mean, so
In 2 days,
usually
yeah.
weekdays I go 1 hour, but in weekdays I go 2.5 hours to
Okay.
accommodate.
Okay.
Okay. So I hope
And there will
everybody
be
is
20 classes, right?
everybody here are part of my community, right? Correct me if I'm wrong.
Yes.
Okay. Because I hope everybody come through my
No, no,
community
no.
channel only.
No, no,
Yeah.
no. I am not part of your community. I got maybe this link from one of my friend. Maybe she
Oh,
watch in your community.
I see. Okay. Okay. No problem. So whoever like part of my community and the group, I hope you are receiving the communication and all. So if anybody wants to like talk to me after this particular class, I'm just pinging my number here. Please try to
Okay.
reach out me on this number. So this is my number. I pinged you. So
97048733984.
yeah. Okay.
045709.
And
Yes.
Prasad,
Yes.
Prasad, do you
Yes,
have
sir.
any questions, Prasad?
We also got out whether which to join like AWS or Azure because mostly nowadays Azure
Okay.
calls are more.
See, obviously, you see Azure calls and AWS calls also coming because I am working in AWS data engineering since almost 8 years. Okay. So that depends. See, maybe according to your CV, you are getting that. I don't know, but I can see even AWS calls also are more. Okay.
But in AWS, they're asking SageMaker also. Like,
SageMaker for data science, not for data engineering.
no, they're asking whether we have knowledge or not on that also.
See, SageMaker means machine learning. So machine learning and all, as a data engineer, you do not require that. But anyway,
They're expecting, right?
yeah.
For
They
10 plus
may
guys, they're expecting.
see data engineering guys will not do data science. So that is a totally different area. If you are willing to support any data scientist, you should know. But that depends. Maybe company to company it will vary. Okay.
Yeah, and the class will be started
Okay,
from
sir.
next week onwards.
Yes, next Saturday at 7:30 p.m. IST. Okay.
And how will you share the recording and other
We
things?
will have a Google Drive. The Google Drive will be there for
Okay.
every class. You will have the recordings, materials, and assignments. Everything will be the Google Drive, and you will receive that.
Oh, okay.
Cool. Okay then.
Yeah,
Okay.
thank you. Yeah, thanks.
Yeah, I'll share this recording also. So please reach out to me in the group. I'll post the recording and the PPT and everything. Okay.
Yes.
Okay then. Thank you so much, guys.
Yeah,
Thank
thank
you
you so much.
very much.